Hi everyone, how was lunch? Good, right? Hope everybody has still some energy for some talks and doesn't fall asleep too easily. Um, Otherwise, I will wake you up, if necessary, personally. So, logging, awesome logging infrastructures using the Elastic Stack. Let's dive into that. Do you work? Yes, or I would want to normally call it like logging all the things, because it's really about just ingesting all the information you can get from wherever you want to have it. So I'm working for Elastic, the company behind Elasticsearch and the entire Elastic Stack. I'm part of the infrastructure team, everything with automation, Ansible, Chef, Puppet, Docker, AWS, Jenkins testing, etc. And then I kind of pipe that with a Unix pipe into developer advocacy, so I'm doing lots of conferences like today. And I'm also running my meetups in Vienna if I'm home at some point. And yeah, that's the introduction. So who is using all the hottest shit stuff, whatever? Sign of hands. Okay. So with hot shit, I don't know, Docker or whatever you want to mean. Who uses more than 10 servers, containers, virtual machines, whatever? How do you log? Like, or how do you keep track of what is going on? If your answer is SSH plus tail, that is probably not the right answer. That gets kind of painful at some point when you lose track, like where am I, which server was that again, okay, I need to hop to the other server, where am I? So that is kind of, if you're still doing that, that is the right talk for you. But kind of the key message is, well, maybe you should centralize all of that, and we will talk about how. So, how are you logging? Who is already using something like ElkStack, Elasticstack from us? Okay, if you, who is using something else? What are you using? Sorry, was it Splunk? Kibana? Well, Kibana, yeah, okay, that is just the front end. We'll dive into that. Yeah, so there are multiple options. I will show you how you can do stuff with our stack. So kind of the key point is, what is a log actually? So for us, a log is anything that has a timestamp and then some log message behind it. And there might be meta information with that as well. So for example, you might have stuff like the server, the process, the user, some other meta information, who is responsible, whatever. So all of that is kind of also nice for a log, but the thing is, you have a timestamp, something happened at some point, and whatever happened plus some metadata. So now how we approach that when we want to centralize that. So I'm always, when I talk about our stack, I'm always starting here, or like right at the beginning. Back in 2010, Shai started Elasticsearch, and it was used for full text search. These guys are using it. I guess I don't need to explain who they are or what they do. So each time you search on their sites, behind the search box, that's actually Elasticsearch doing the search for you. And then two more products were started by the community, and then we always like to say they joined the family. So their authors probably wouldn't want to hear like they were bought, so we always say they joined the family. And the first one was Kibana. This is kind of the visualization of your data. It's just like you have lots of data stored in Elasticsearch, and at some point it might be nice to have an overview what is actually going on. What data do you have in there? And we also call it the democratization of data, because it's just everybody within your company with minimal training can actually see the data and kind of try to get meaningful information out of that. And then we somehow need to get logs or other data in there. That is what Logstash is all about. So Logstash has already the log in the name. But it is not just about logging. It has more than 200 plugins, so it can get data from lots of sources. Then it can transform or filter or enrich your data, and then store whatever you have processed, either in Elasticsearch or in another system. So you could read data from TCP, UDP, SNMP, queues, Twitter, WordPress, what else? And then you can do something. The enrichment would be, for example, I have an IP address and I want to know the geolocation and, for example, the city name of that IP address. So I can actually know which cities are my users from, or which countries are they from, so I can target them better or provide the right translations for them, or whatever you want to do there. And then you might want to store that information in Elasticsearch, so you can make use of it in Kibana again, or you can also just store it as a plain text file, for example, on Amazon S3. That's also totally possible. And these three together, Elasticsearch, Logstash, and Kibana, they form the so-called ELK stack, ELK. And we even had the ELK as a mascot, and I even have the plushie ELK at home. So that is widely used and a very sticky name, and everybody still refers to it as the ELK stack. And that is widely used. For example, CERN, with all their thousands of computers, they are logging from their Salesforce in the cloud. They're using that to log data. Goldman Sachs is a slightly different use case. Every now and then something bad at Goldman Sachs happens, and then afterwards they have to pay a big fine. And after some fine, they decided, well, maybe we shouldn't pay that 50 or 100 or whatever million fine. Maybe we should just build an audit and compliance platform to avoid doing the bad stuff. So they built something with the ELK stack, and it's also widely used for credit card fraud and many other use cases. So it's not only logs, but it's also like whatever data you have and whatever is important to your business, you can probably store it, visualize it, and then take the right actions afterwards. And that worked all well. And then this little fellow came along. That is Beats. Beats are kind of a family of lightweight agents or shippers. Logstash is very nice and versatile. The problem with Logstash is it's written originally in Ruby, by now JRuby for performance reasons, but you always need the JVM. And people, especially if you're not a Java shop, people are not that happy to put Java on your server just to get the logs. And that is what Beats tries to combat. Beats are written in Go, so that you have native system binaries and you don't have any dependencies. And they're built for one specific use case, for example, collecting log files. And that is why Beats as well joined the family and is now part of the stack. Now, the only problem is in ELK, there is no B for Beats. So we didn't kill the ELK. That is maybe too drastic here. Let's say that the ELK is retired. It is not like hung up like that somewhere. It's still living in ELK heaven and having a good time. So we didn't kill the ELK. We're just trying to get rid of the ELK name. And every time somebody does a meetup, for example, and says, we'll talk about the ELK stack, we're kind of happy about that people like our products and talk about them. But we try to get rid of the ELK name, so then somebody from the marketing team will raise the so-called ELK alert, and somebody will reach out and try to tell them, well, it's not called ELK anymore. We tried with something else. First, this one. This is the BELK, or the ELK bee. And you can see it's a bee, and it has the ELK horns. And marketing liked it at first, and one of my engineering colleagues liked it so much, he even produced a sticker on his own. The only thing is, it is not really scalable, because what happens if, no plans at the moment, but what if we add more products to the stack later on? We will need to find or make up another animal, and that's kind of cumbersome, and then we need to change the entire marketing, so it does not really scale well. And since Elastic is all about scaling, marketing decided, well, that's not going to fly. So we stuck with the more boring option, which is just calling it the Elastic Stack. So when people are referring to the ELK stack, actually it should now be called Elastic Stack, but it's still the same thing. It just includes Beats now as well. And this is what the stack look like. So you have Beats, which are like the lightweight agents or forwarders. You have them on all your servers. That could be hundreds or thousands. Those can either write their data directly to Elasticsearch, or if you need parsing, you can either write it to Elasticsearch or Logstash. So Logstash is not going away. Also, all the plugins Logstash has, that is still a sweet spot. You still want to use Logstash for that. It's still very powerful for parsing data, enriching data, like the geo-IP lookups. But you don't need it for all the use cases anymore. And then Elasticsearch stores the data, and you can query it. And Kibana is there to visualize it, kind of sitting on top of it. Sometimes people ask, like, what is the database behind Elasticsearch, or how does it actually store its data? Well, it's using Apache Lucene. That is actually what is doing the hard storing and searching work, and there is no other database or data store involved. This is like, you just use Elasticsearch, it has Lucene built in, and that is doing everything you need. So there is no need for any other storage or anything around that. And recently, like 2 or 3 weeks ago, we released the version 5 of everything, which might sound confusing. If you have been using our products before, Elasticsearch was at version 2.4, Logstash was at 2.4 as well, Beats was at 1.3, and Kibana was at 4.6. So this kind of shows, since all the members of the family joined at different points in time, they also had different version numbers. And even for us, it got pretty confusing. So if you ask me, like, what is the right Elasticsearch version for Kibana 4.1, I'm not really sure. And we have a compatibility matrix, and that's, yeah, you can look it up there. But going forward, we've decided from now on, everything will have the same version number. The next available version number was 5. So the entire stack is now at version 5. And we released 2 days ago, or 1.5 days ago, we released 5.0.1. And that is the current version of all the products, and it's just one version number 2. Don't confuse you and also not confuse us too much anymore. And you can also see, since Elasticsearch jumped from 2 dot something to 5, it got way better since the version number increased so much. So it's a much better product now as well. So how do we make money? All our Elasticstack components, like top left corner with the dashed line around it, that is all open source. And even if you're a paying customer, you will get the same binaries as anybody else. Like some of our competitors or some other people in the data storage space, they often have a commercial version and an open source version, but we don't believe in that. A, out of principle, and B, because we admit to being lazy. And being lazy is often a feature in IT. So what you normally do is, if you have the commercial version, is you develop the commercial version, you test the commercial version, then you remove some other features, then you would need to test again, which nobody does, and then you release it to the community. And we kind of wanted to skip that. So we just have one version, and that is the same for everybody. What we do have is, if you do not want to store it yourself, we have it hosted as a service. In the cloud, it was previously called Found, but nobody found, so we had to rename it to Elastic Cloud. That is actually a different thing than what AWS provides. So it's still hosted on AWS, but it is kind of a competing product. And every now and then people come to me and complain about something, and often it turns out, well, that's the AWS service. So yeah, we don't advertise that one. And we also have support that goes hand in hand with commercial extensions or plugins. But these are really just extensions you plug into your existing products. So if you need anything around security, alerting, monitoring of your cluster, PDF reports, or exploring your data in a graph, those are all commercial extensions. But I'm just talking about the open source stuff today. So what are the beats? What can they do for us? So we have first off the file beat. This is just, you have a log file and you want to get that log file and centralize it. I always call it like tail F over the network on steroids, because it's really just doing that. It's just reading the file, taking it, and sending it over the network. It doesn't parse anything, so it's very lightweight and just ships the data off so you can centralize it elsewhere. We have metric beat, which was called top beat previously. So it did what top does, CPU, memory, etc. But it now can include metrics from applications as well. So Redis, Nginx, Apache HTTPD, MySQL, Postgres, MongoDB. So it can ingest metrics from those systems as well. That is why it's called now metric beat, and just stores whatever metrics you want to have. And then we have packet beat. Packet beat is like Wireshark. Wireshark is great as long as you're on one system. Otherwise, it gets a bit painful. Again, if you have more than 10 servers, you will need to capture packets on all of them, and then you will need to kind of combine that or correlate that, and only then Wireshark can actually show you what is going on in your entire system. And PacketBeat is using the same base library, libpcap, and it's extracting network packets and reads the headers. And just from the headers, it can gain lots of information. For example, it knows this was the request, this was the response corresponding to it. The protocol was HTTP. The response code was at 200. The whole thing took 100 milliseconds. And the URL you accessed was foobar. And you don't need to instrument your application. Just from these headers, you can see which are my most popular URLs, which are my slowest URLs, what is my, I don't know, median response time or my 99th percentile response time. All of these things is supported just by PacketBeat. And it supports lots of protocols. So we support DNS, HTTP, the database protocols, so you can get lots of information just out of those. And if we don't yet support the protocol, we still have something called flow, where you at least see, okay, this server communicates with this other server. And then you know, okay, who is communicating with who, how long does it take, how much traffic do you have, how many packets, so you get the general overview of how your system is doing. And then we have WinLogBeat, which is more of an honorary mention because I try to stay away from Windows normally. If you need to manage Windows servers, I'm sorry for you. But we also have a solution for that. It's just that Windows has its own weird logging thing where you have an application to see what is going on in the server. And WinLogBeat just takes that information and also stores it in Elasticsearch. So you have a central part and you can correlate that with your other logs and everything. And there are also community beats. So it's not just us providing beats, but you can write your own easily. So we have a doc beat. At first we called it, or the community called it Docker beat, but Docker is feels very strongly about their trademark and they sent the lawyers right away. So they had to rename it, and at first we thought about just dropping the E, so calling it Docker beat. But we now stuck to doc beat, and that is kind of fine. And its functionality will soon be included in metric beat. So whatever Docker containers you're running, we can also extract the meta information and resource usage from those. We have a Spring Beat from the community. If you're using Spring Boot to write your application, you automatically expose endpoints like metrics or health. And we just query those endpoints in a regular fashion and then store the results. So you can see how was the health, or how was the response time, or how many requests did I have over time. And based on that, you can easily customize that for your own application. You just need to have some endpoint from which you can get insights, and then you can query that and store it easily. And you can, of course, write your own beat. So we provide a base library, the beat generator, and you just need to fill in kind of the holes. And the base library does everything like talking to Elasticsearch, talking to Redis and Kafka, TLS encryption, retries. It does all of that. You just need to somehow give it the relevant stuff you actually want to store. For example, one of my colleagues is a hobby DJ, and he wrote a totally pointless beat, but just to show you what is possible. He ingested one MP3 file, so you can call libbeat, or you can call his beat, I don't know, it's music beat or something, and you can call that on one MP3 file, and it will actually extract the amplitude of the song, store the amplitude in Elasticsearch, and then he can visualize the amplitude in Kibana again, which is pretty pointless, but it's just like, yeah, you can take whatever information you have, store it in Elasticsearch, and then visualize it in Kibana, and you just see what is going on. So let's do something fun. Like, I'll get rid of you. Let's just refresh that. So we have, this is all in one virtual machine running. And I have different data. So I have my packet beat, file beat, and metric beat running, and it's monitoring its own virtual machine, so it's all self-driving. So for example, for packet beat, I'll pause that for a second, otherwise it keeps jumping around. Here I have packet beat, and you can see, okay, this was one request response I had. So for example, the transport protocol was TCP, but we could, and the type was a flow. But we could, for example, say I want the type to be HTTP. And you see, okay, we had 85 HTTP requests over the last 15 minutes. And these would look like something like this. So you see, okay, this was a response code 200. We see, okay, this was the path we requested. It was a post. We see, okay, that took quite a long time for whatever reason. But you get all of these informations, and you can then just drill down and see, okay, what were specific URLs people asked for, and how are my requests doing over time. We can also show like FileBeat. This just collects local log files, and obviously I didn't collect any local log files in the last 15 minutes. No, actually there is no type HTTP here. So over the last hour I collected 532 log events. You can see, okay, here I was at lunch, the laptop was sleeping, so no logs then. But you could see, for example, this was a Kibana log, so Kibana logs the requests, or it did here. And you can see, okay, this was a post from my user agent, and I was just requesting some URL. So you have everything you have in your log files. And for example, metric beat just shows you system metrics of what is going on your system. So here, let's see what that is. That is a process. The process I'm seeing here is, yeah, okay, called Ksoft RQD. We could also say, okay, we want to have the process name. Let's see, I assume my process name could be Kibana. Ah, no, that is actually just Node then. And you can see, okay, these are the events for my Kibana visualization. The process itself is Node, since this is a Node app. And you can see, okay, it's running. You can see how much memory it's using, how many open files it has, what the process ID is, when it's sleeping, when it's up. So you have lots of information extracted here. So you can just see what are my processes doing, when is something running amok, and stuff like that. And just the log files, they don't give us that much information. So we can actually visualize stuff that is going on. So I can, on visualize, I say what do we want to do? Let's say we want to create a pie chart. And I have an index called person. I've just generated some random persons here. And I want to, for example, say, just give me, let's just split up over country. Let's see what countries I have in my data set here. So I have address country. I run that query. And over the last hour was not good. Like I have created or inserted my people based on their birth date. So it is from 80 years ago, I created people. And when I run that, you can see, okay, it is randomly generated and pretty evenly split. So we have France, Italy, England, and Germany. And you can see, okay, there are minor variations, but in general, we have people from these 4 countries. And then we could say we want to drill down. We want to see which are the most common cities where people are living. So I can say, okay, I want to slice that further down. I split that up over a term again. And the term I'm splitting this over now is the city. And then you can see within the city, we have, for example, in France, the biggest city is obviously Nantes, which is not, but well, that is how my data is generated randomly. And the second biggest city is Cergy, and the third biggest city is only Paris. But if you hadn't visualized it, you had no idea what the people are from. So the most common city in your data set for France is Nantes. Or for example, for Italy, most of your, the people, I don't know, you have in your data set who visited your site are from Turin. That is a nice way to visualize it. And you have some minor variations to actually make that look nicer if you want to. And we could drill further down. So we could say, I want to sub-bucket that again, and I want to split that. And I want to split that on terms, and then I want to see like how is the gender distribution there. So you can see, okay, within France, within Nantes, female has 51% in there. Over the entire French data set, 49%, and no, Nantes has 49% within France, and France has 25% over my entire population. And so you can drill down and see actually how is my gender distribution, or where are my people from. For example, we have lots of different visualizations. For example, we could do tiles, which is basically a map. So we can say, okay, just show everybody in my data set. And we can see, okay, people are living here in Europe. Let's just jump in there. Let's go for Paris. And you can see, okay, data is not generated in any clever fashion. It's just taking a random or a square, and then people are generated randomly within that. And why Sergi is so big is because my French colleague, who is from Sergi, who created that thing, yeah, he just generated most people in there. But you can see, okay, it's just a square where people are generated. And we could, for example, now filter that down again. We could say, okay, we want to see where only the male population is living. Watch the bottom right-hand corner, like there are the numbers. That is the only thing that will really change if I run the query. And you can see, okay, now it just filtered down, just show me the male population on my map. And yeah, that is easy. We also have dashboards. Dashboards are just giving you an overview. We've built them for the beats we provide. So just to show you what is going on. For example, here I have one overview of your processes. So we have 123 process IDs and 81 processes running. And we could, for example, say, give me the processes which are using most memory. So to little surprise, Java is leading. Any ideas which the Java processes are which I have running in my virtual machine here? And yeah, Logstash is true. That is the JVM now. And Elasticsearch itself is also written in Java. So those two processes are taking up nearly 3 gigs of memory. Then I have Node, which is Kibana. So Node plus Angular 1. And then we have a few beats running. Metric beat, file beat. Packet beat doesn't even show up memory-wise here. Maybe CPU-wise. But yeah, you can see, okay, I've run my Ansible playbook, so I've just installed everything. And then you can see what is taking up CPU or not. And we have also a visualization down here. But 80 years was not a good time frame. Let's go back to the last 30 minutes again. That is better for the visualization part. And you can see, okay, this is how Java, for example, how many resources Java is taking up, both CPU-wise and memory-wise. And you could change the color here. If you don't like that color, you could, I don't know, recolor it here. Not sure that is much nicer, but yeah, it's sticking out. So you can see, okay, Java is pretty memory hungry in my example. And we have the same thing we can do for if I had imported that correctly, I haven't properly imported my packet beat dashboard, but we can just build that ourselves. Like, we won't build the entire thing, but we can just create that easily. For example, we want to see how many HTTP requests did we have over time. So we're saying, okay, packet beat to me. I want to split up the x-axis as a date histogram, so I see over the last 30 minutes, how many requests did I have over one time span. So you can see, okay, this is the distribution of my HTTP requests. And now I could say, for example, show me, I want to split the bars, and I want to do that on terms. And the term I want to know is if your HTTP, I want to know the response code of the HTTP request. And you can see, okay, most of those were 200s, but here we had some redirect. Something weird happened here. Or if you have a live application, probably at some point your 400s or 500 jumps up. And then you will know, okay, I need to fix something here. Like, what did I change? Did I deploy a bad version, or why is this so broken at the moment? And then this is only always based on one index or one data type. We have, it's called timeline now, which is querying data over multiple indices. So for example, we can say, okay, data of all my indices looks pretty regular. I want, for example, to know how do the number of entries in my file beat compare to the number of entries in my metric beat. And you can see, okay, let's add a label here as well. Okay, metric beat is just doing way more stuff, whereas my file beats, yeah, they're just kind of hidden behind that. So Yeah, metric beats is counting way more. And you can fine tune your queries and you can compare different metrics and visualizations here. So you can see what is actually going on. So, finishing off with the slides. I always compare the stack kind of to Lego because you have these building blocks, but there is some assembly you still need to do yourself. It's not like a final solution just for one thing, but you have the building blocks and then you can do lots of different stuff. Like you can use it for business data, you can use it for your metrics, your logs, your analytics, your security. All these things are kind of possible with the stack. You just need to stick the different building blocks together in the right fashion. Yeah, that was the stack we've talked about. And if you want to try it yourself, I've just run a virtual machine here. For the demo, you can just clone the repository. It needs Vagrant and VirtualBox. So you just run Vagrant up. It will download all the dependencies and just configure it for you. So you can easily just run that yourself and try it at home and see how it's working out for you. Other than that, any questions? We have still 3 minutes left. Yes? Okay. So the question was, what is the difference between Logstash and Kafka? They're having different purposes. So a Kafka is a queue, and it's like you throw in stuff at one side, and you can take it out on another side. So you can decouple producers and consumers. But Kafka is often used in combination with the Elastic Stack. So the big users and all the fancy startups from Silicon Valley, they all have to use Kafka. So they just have the beats, they throw in their events into Kafka, and Logstash then takes that out. So Logstash is not a queue, it's more like a processor. So it's just taking something, doing some work with it, and then throwing it further. So it's actually doing the work, but it's not a queue where you just decouple different systems and you can buffer events. But it is a common combination to have Logstash and Kafka and then Logstash consume out of that. Any more questions? Yes.
Yes. Earlier you mentioned this Amazon thing, Elasticsearch.
Yeah.
Is there any alternative to that, to replace that
and
make it work in AWS?
Well, so if you're having your services running on AWS, you basically have 3 options. First, you can run Elasticsearch yourself, which is you have tight control over it, but it's more work and you're reliable, or you need to keep it up and running, do backups and everything. So there's kind of an investment and a learning curve. Then you can just use the service provided by AWS with the main drawbacks that their versions are normally very outdated. And well, they don't have they don't have any of our commercial extensions. And we also provide Elasticsearch and Kibana as a service on AWS. With the advantage we provide, like the day we release something, the same day the version becomes available on our cloud. And we also provide our commercial plugins with that. So you have security and alerting and everything. We don't license that to AWS, of course, to have a competitive advantage there. So if you want to host yourself or go with our cloud service, I mean, you can just spin up a cluster and see how our stuff is working for you. I think prices start at $45 a month, and you can just select the region and say, okay, I want it to be in 1, 2, or 3 availability zones, and I need that much memory, and I think the factor is 1 gig of memory comes with 24 gigabytes of disk space, and then you can just scale it up and down like how much you need, and we will do that for you. So yeah, and you get the support by the core engineers, of course, in the background. If something happens, we will take care of your stuff.
Okay, thank you.
Any more questions? But I think time is up. So thanks a lot. Enjoy the rest of the conference. Have a good day.